Oh, well, let's sing, Marcos. Let's sing.
Yeah, well, you just start. You start.
You know how to sing. Oh, yes, 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 yes. Well, Tasso is here. But anyways, in between this session and the next one, we invite everyone to join us here in front for the official photo. Please, remember that. So I'm very pleased to introduce Tasso Azevedo. Tasso works with forest, climate, and sustainability. He's the general coordinator of MAP Biomas network, land cover and land use change monitoring initiative, and chair of the board Connection Forest People Initiative. Tasso was founder and general director of Imaflora, general director of the Brazilian Forest Service, designer of the Amazon Fund, the first concept for tropical forest forever facility. He was also the creator and coordinator of SEEG, the system to estimate greenhouse gas emissions in Brazil. He is an affiliate scholar at Princeton University. Tasso, the floor is yours.
Ele deu stop ali. Sometimes the old style, just take the cable. Time for the picture. Okay, so, see, Brazil is the fifth largest greenhouse gas emitter in the planet, so just after China, US, India, and Russia. But different from these four first ones, which 3/4 of the emission comes from burning fossil fuels, in our case, this comes from the way we use the land. So, this realization, which comes from another project that I coordinated for many years, which was the estimating greenhouse gas emissions in Brazil. It gives us the kind of the urgency to actually understand what really happens on the land. If you want to really understand not just the emissions, but what is causing those emissions, also the removals and so on. So the idea of Mapiomas came from the fact that for many years, we have been monitoring the Amazon and the other biomes, but mostly for a process, not a land cover land use, which is deforestation. Deforestation is a process, not, we don't say what is before and after, you just say there is a deforestation event happening there. So the idea was to really understand how the land use is changing over time for, from different types of land use. After you clear cut, what happens, what type of land use you have, and how this is being converted over time. So that was the original idea. To do so, we assembled a network of several organizations. It's kind of, if I go too close, it's okay like this? It's too much. So we assembly a group of organizations, which includes universities, NGOs, and some tech startups, most of them that born in the project, with young students creating their own initiatives. And with all those grouped together, the idea was to use remote sensing and a lot of the knowledge of the different organizations in the subjects that we were mapping to build up time series that explains how land use is changing over time. So if you have to explain in a simple way, is like we take the satellite image, then we broke the country in the size of the pixel of the image, which is 30 by 30 meters with the same Landsat. And then instead of mapping a object, which is the normal thing that we do normally, like you look at the map and then you find out, for example, a lake or a farm or something like this, what we try to do is actually to tag each one of those pixels if it was a territorial unit. And then we tell the story of each pixel, one by one. So instead of producing maps by mapping one every year, what we do is that we tell the story of each piece first, and then when you put together all those pieces, we can have a kind of a cube, and then this cube you can slice the cube, and then you can get the map of any time in the last 40 years. So this is we process everything pixel by pixel, a lot of machine learning, AI, etc. And it's all produced on the cloud. And so the idea here is, by having everything processed on the cloud, is to allow for many people to collaborate on the same process of mapping at the same time. So everybody is mapping different things, but using the same infrastructure. So it allows for somebody that is in São Paulo and somebody that is somewhere in the middle of the Amazon or in the Northeast to actually have exactly the same capacity of processing the data. And the other thing that is interesting is that we kind of designed this project in a way that this is updated every year. So every year we produce a new collection of data that we will be making it better every year. So like when we launch a new collection, like we did this year, we process all the maps again, and we are adding classes, so you can have more details in the map. We are adding more years, so you can see more, a larger period. And we also try to increase the accuracy. So just to have an idea, the first map in 2015 has just 7 years of data and 7 classes. And the accuracy was even not possible to calculate because the map was very bad. So today the maps have 30 classes and have 40 years of data since 85, so one map for each year. And the accuracy is close to 90%, which is well above the maps that you see on land cover land use globally. Now, so the end result is one map for each year, which will have all those classes. So different types of forests, different types of native vegetation. So you have, like, for example, mangrove, wetlands, grasslands, etc. And then you have also different crops, mining, urban areas, and so on. So this goes to a platform which is an open platform where you can see all the data, and you can see every time you see something on the map, you also see on the statistics. So it's a tool for the users to grab the data directly and then make their research or their development over that. It's designed also in a way that, I don't know, okay, that you can obviously zoom in anywhere. What you see on the map is the pixel, so there is no like kind of a filter that aggregate that. It's basically you see pixel by pixel. And you can actually see the story of each pixel. So if you click anywhere on the map, you will see the history of that pixel. So this pixel starts as forest in 85, stays as forest until, I don't know, maybe, I can't read this, but like, I don't know, maybe 93, it was clear cut, transformed into pasture, as you see in yellow, and then stays as pasture until 2013, it was converted to soybean, has been soybean since then. So because you have each pixel, each one of the 9.6 billion pixels of Brazil, over time, you can actually have the history of any part of the country. Actually, you can see the history, how the land was changing over time. So, for example, in this particular area, around the area that I'll show you, we are seeing is that the green converts to yellow, which is pasture, and then the yellow converts to cropland. So it's kind of also a dynamics that everybody that lives in the Amazon knows that is the most common change. And it's designed also in a way that you can actually choose any piece of land, make a box or a design, and it will tell the story of that piece of land or give you the statistics over time, how the classes are varying and so on. So this is also a tool that was thought for not be the data that create the impact directly. So we joke that in Mapbiomas we don't have any impact, it's zero. The impact is the users. So the users take the data to actually use this for impact. So the whole thing is design and think in a way that it can be used by as much people as possible for their day by day. So, for example, you can choose any type of territory. I don't know how to do this. Yeah, any type of territory. For example, you can choose one of the 27 states, one of the 5,000 municipalities, any one of the 3,000 protected areas in Brazil, and for each one of them, you will have the same story. Like you can see the whole history and so on. So, for example, here we have the state of Pará, and if I kind of click on you can actually interact on the map. If you click on Paragominas, the symbolic city in the state of Pará, you can see like the municipality, you can see all the statistics, the story there if you want, but also you can choose to compare any pair of years to understand how is the change happening, which ultimately is what we want to understand, like how change is happening. So you choose any pair of years. In this case here, I choose 2008 to 2024. Why? Because there is an agreement in Brazil that the soybean traders will not buy soybean from areas in the Amazon that was converted after 2008. So the idea here is to see, okay, I want to find out where are the areas that were forest in 2008 that now are soybean. So I can avoid to buy from those areas. So you basically, you choose to see a Sankey diagram that shows the two periods, and then I fix soybean at the end, like on the last year, and then it will tell me how much you have of forest, agriculture, pasture, etc. on the same areas back in 2008. So you know exactly what is there. In this case, it's 27,000 hectares in Paragominas were forest in 2008 and now are soybean. So this is for other types of users, not just researchers, but people also working on the day by day, on the companies, on the banks, and so on. Okay, this is also thought to work for every property in Brazil. So if you choose any one of the 7 billion properties in Brazil, you can actually have the same type of information for each one of them. You can upload your geometry, your shapefile, and have the same thing. But when you look to all this data together, you can have a lot of insights, right, on things. So just like a simple thing, for example, how was the transformation of Brazil between 85 and 2024, right? So what we see here is that we lose in all Brazil 62.8 million hectares of high dense forests, right? And then we lose also 37.4 million hectares of like this open forest, which we call savanna formation in Brazil, another type of forest. And what gain? We have gained 62 million hectares of pasture and 44 million hectares of agriculture. And by the way, pasture starts to grow in size by 2000. So we still gain pasture, but we are losing a lot of pasture for agriculture also. So the area of pasture in Brazil now is going down. So things that you can learn on that. And you can also think about that in different types of regions. So for example, here is each one of those pairs are one state in Brazil, right? And so the first block is how was the distribution of the land use in 85, and the second block is in 2024. Like summary of that, 26 states lose native vegetation. Only one state increased native vegetation, which is Rio de Janeiro, by an effect that happens on the last. So if you are from Rio, congratulations. You have that. Now, if you take from 2000 to 2024, then you also have Espírito Santo and São Paulo also growing. See? Why? Maybe it's because we approved the law of Mata Atlântica in 2000. We don't say that, but we're just saying like, oh, you can explore that, right? You can explore the linkage between the decisions on the public policies and this information. Now, with this data, we also start to create sub-products, which is attending to specific needs of certain groups. So for example, because we have a map for each year, we cannot calculate the deforestation, right, for each year. But I can calculate the deforestation of primary vegetation, but also calculate the deforestation of secondary vegetation, which is, nobody looks at secondary vegetation, right? So we don't even consider that. But last year in Brazil, there was 1 million hectares of deforestation just on secondary vegetation, on top of what we have in primary vegetation, right? The other interesting thing you can see, for example, is the intensity, or how soon, when did you have the last deforestation, and things like that. The other way is also possible, right? If I can calculate the deforestation, I can also calculate the regrowth. So by doing this calculation year by year, it's possible to estimate the area by age. So not only you can map all the regeneration, but you can also calculate what's the age. So you have interesting things, for example. The age that you have more deforestation of secondary vegetation is 6 years old. Why? Why? For the Brazilians. Because the forest code assumes that up to 6 years is not a new deforestation, right? After you have 6 years is a new deforestation. It's interesting, right? That you can capture this on the data, right? The other interesting thing here is that we find out that Brazil has today 34 million hectares of secondary vegetation. Everybody knows this number, like Brazil has a pledge to restore 12 million hectares that they made in 2015. But in 2015, we didn't know that we have 34 million hectares of secondary vegetation, right? So it's interesting that kind of even the decisions we take on the policy, if you don't have the information, it may be meaningless afterwards, right? Because what's the point of saying that you have a target of 12 million hectares if there is this much happening? By the way, just another curiosity, if you sum up all the projects that kind of actively decide to plant to restore in Brazil, even if you make a big effort to sum up everything on the last 40 years, you will not get 1 million hectares. So the 34 million hectares that we have regrowing in Brazil has nothing to do with active planting. It's just like nature recovering. So if you have to have a policy to recover forests, what is the most important thing to do? Stop deforestation of secondary vegetation. That's the most effective. It's not planting trees. Planting trees is important, but it's not the most important if you think about what's the nature can be done. No? Just interesting insights. Okay. I will just pass here. This. Go. The other two things that I just want to call the attention because it's interesting is like, it's very difficult to represent on land cover, land use maps, water. Why? Because water, it's moving, right? Water, sometimes you have the high season, you have the lower season. Sometimes the area will be wet or be dry. So because of that, we decide to make another platform, which is inside Mapiomas, where we map the water surface every month since '85. So the idea is that by capturing every month, so you can understand the dynamics of the water, and then we can extrapolate from there what we want to consider kind of a stable water to put on the annual map. But since we map every month, so we decide to build a platform with the information of every month. And so you have, for example, here is the darker color is the areas that were that have water for most time in this whole period, right? And if you have the same pixel has less time it was repeating, then it will have a lighter color. This is another way of seeing the water is to classify the water streams into artificial or the water bodies into artificial or natural. So for example, São Paulo, 75% of the water surface in São Paulo is artificial. It's like lakes from hydropower, etc., etc. If you take the Amazon, it's very small, but it's concentrated on hydropower. But if you zoom in Rondônia, the frontier of the deforestation with the Amazon, there is 100,000 like reservoirs in farms that grew up on the last 20 years. So after deforestation, it's getting drier. The farmers make reservoirs. And so this is leading to less water going to the natural water streams. And then you can think about all the potential impacts. So there is a lot of people now studying this to make the relationship between the building up of those reservoirs, which the farmer is doing just to get some water for the animals or for something like that, and maybe we are inverting the machine. Like less water going to the water streams where you have the trees to pump, and then you have less rain you have more dried seasons, more dried seasons you make more dams, and maybe we're just like inverting the machine. So yeah, kind of curiosities. And just like to have a reflection of like the strange year of 2024, each line here is the water surface month by month in the Amazon. Okay, each line is 1 year. So this is the average, and that was last year. It's not that it was like below what you have, but it's like nothing comparable, right? And it's interesting that in the beginning of the year, it actually was higher than the average. And then at the end of the year was like this total disaster, right? And that's the opposite, same year in Pampa, Rio Grande do Sul, where we have this big flood, and etc. So you see like, it starts below, it's not crazy, it starts below, like there was less water, and then suddenly, poof, you have this, that's climate change, like that's crazy stuff. Okay, we have also the similar thing for fire. The question on fire is that you can't see the scars of fire if you take too much time to look for the scars. So here the idea is to map the scars every month so you can capture all the fires you have during the year, not like the fire spot, but what has been burned. And then there is many interesting things like which month you have the fire, etc. What's the size of the fire? But the staggering figure for me is this one. 24% of Brazil burned at least once in the last 40 years. This is the largest area of fire in any country in the world. So kind of, we think about California, we think about like Australia, like Canada or Portugal, Russia, forget it, that's us, right? Okay, cool. So just to finalize, all this this work, and especially all the codes, all the methodology, etc. It's all open and free access, so anybody can copy this and do it. So thousands of institutions using this. There's about 4,000 scientific papers using Mapioma's data, only 29 from Mapioma's team. So that's what I said, like we do the data for the others to actually create science over there. And then because this is open, it starts to be building other networks in other countries. So all the countries in green here, there is 14 countries, all South America plus Indonesia. There is a local network with several organizations doing the same thing we do in Brazil, but in their respective countries. Every country has its own organizations doing the mapping. This year we start also in Mexico, India, and GRC. And that's our, so for each country there is a platform of maps. So each country will map whatever they think it's important, and etc. And to finalize, this is our plan for the next years. It's very light. You can see the rest of the world, but you are there. But the idea is to move to the other countries in Congo, Central America. There is a demand for Kenya and Laos and Malaysia. So these are places that if there is demand, if there is groups locally that are interested to start something like this, we will collaborate, share everything, training, everything, the infrastructure, so we can have this capacity in other countries. At the end, I just want to say something like this. Maps is power, right? If you have maps, you have power. But the really powerful people are not the ones that have the maps, are the ones that produce the maps. So this idea here is about really empowerment. Like it's empowering in every tropical country in the global south to be able to produce your own maps and then control your own destiny in terms of thinking about the reality of your territory. That's it.
Thank you very much, Tasso. Very encouraging way to control all the deforestation in our country and in the world. Well, I have the pleasure to invite Mônica Moraes, a friend from Bolivia. She studied biology at the University Mayor de San Andrés in La Paz and obtained her master and PhD at the University of Aarhus in Denmark. She has been a full-time professor at the Universidad Mayor de San Andrés since 1990 and researcher on palm species native to Bolivia at the National Herbarium of Bolivia since 1984. She was part of the science panel of the Amazon that prepared the region for COP30 on the Amazon we won. Mônica was appointed full member of the National Academy of Science of Bolivia in 2008 and is the first woman to ever assume the presidency of the Academy of Bolivia, term 2021-2024. She is a member of the World Academy of Science. Thank you for coming and joining us. The floor is yours.
Thank you very much, Val. I would like to thank to the Brazilian Academy of Sciences, especially to Helena Nader and Marcos and Vitor and all the staff. You are doing an amazing work. And I really appreciate inviting me to join this important meeting that is going to make a statement for the world, and that will be the COP30 in Belém. Well, I'm going to make a kind of merge of most of the dynamics and processes we have considered in the previous presentations. And this is going to deal about the impacts of the global climate change on biodiversity, but also to people. And I'm kind of, putting in bold words some of the most important things that are happening and getting very negative conditions for species in the planet, but not also dealing about habitat loss and fragmentation, but also affecting life cycles. And as you have heard by now, is that drought and all these floods and things that are giving a catastrophic conditions are impacting the normal life as we have known before. And this extreme weather and droughts also are giving some indications that perhaps we are entering in a very bad conditions for life. But also species are starting to migrate because they are trying to skip all these heats and droughts and rising temperatures that are affecting the normal status of this biodiversity. If we consider, for example, habitat and ecosystem disruptions, we can consider at least these three impacts, like habitat loss, species migration, and ecosystem changes. And perhaps it's every one of these processes are giving and making worse the survival of species, destroying habitats. Mostly of the examples that we have learned by now is that species of animals and plants are trying to move upwards, escaping from these heats on, for example, from the Amazon to the Andes. And also the ecosystem changes, which is, it's taking over longer periods by changing, and this is affecting also the reduction on water balance in most of those ecosystems, and this has resulted in almost 60% of vegetated areas in the world, and giving this plenty number of fires along the planet. The species migrations that was meant to have plenty examples on these new conditions to move some communities to another ecological communities, like building up new shapes and new structures. But this is also making more difficult for humans to establish or stay in some sites. In the other group of impacts are considering this disruption of life cycles, where I'm going to take a study case later that the timing mismatch for natural cycles like flowering and producing fruits for harvesting by local people is also starting to make some indications that, yeah, it's happening and it's changing between cycles of years. And also the breeding and food sources for human, for example, is also having this out of synchronicity between, for example, pollinators and many animals that are distributing some seeds and fruits, and these are threatening the survival and breeding processes of these species. The global warming is also like changing the composition of these communities of insect pollinators, and also the photoperiod that is changing every cycles of years, not every year. Maybe you have noted every time we saw this data, this information is changing not only year after year, but group of years. And this is also affecting the flowering and leafing phenology. That means that it's the reaction of nature is also having another result. And the next group of things are, or events are, the extreme weather and other impacts, like increased extreme weather, that bushfires, droughts, storms, floods, all these stochastic events in the planets. We are learning that these probably are the most dangerous processes. And also the increased disease risk for diseases to spread, and also affecting humans by some pandemics, for example. And invasive species also, they have found a new free path for opening conditions in removing these climatic barriers and spreading along and competing with native biodiversity. For example, in the Amazon, please note, I don't know, maybe here, please note the uprise. It's affecting this deforestation. We have, it's the second time we are seeing this picture. And we can see that climate, stream, and human activities are also encountering this bad moment for the Amazon nature. And between, many times we are having this information that we have this recorded fragmentation of the forest, and this is happening mostly between, you can see in Brazil, in Bolivia, they are showing the higher deforestation and also loss of hectares, almost reaching 7 million of hectares in 2024. But what are the impacts for human species? This climate change also, we have to consider that the greenhouse gas emissions have been human-made, created. So, but it's being the primary cause for global warming. Well, we have now these events that are being affected in a very big areas, with heat waves, hurricanes, floodings, wildfires, and many others, like soil degradation as well. You know that the planet is offering only 10% for agriculture in total, and we are improving by putting more chemicals on producing more. But this is happening, is impacting also people that is more vulnerable in conditions of survival or accessing to nature and getting some incomes. Not only floods, but droughts. Droughts have been affected a lot for these populations that depend, that rely on these natural resources. And you can see that the impacts for people is having many chapters that are together and belonging to what is happening to nature. And summarizing this global outlook, we can have these four major things, like it's having really a profound negative effect on biodiversity and with it to humanity. And the rise in temperatures, for example, for Bolivia, we know that it will increase by 3 degrees in 2050, but it started already to reach more or less 1.5 degrees by now. And it implies the loss of natural habitats, desertification, freshwater shortage, ocean acidification also. And the third one is that this is generating pressure on ecosystems, not only natural, but also transformed by the people. And this is having consequences that is affecting the extinction and survival of species. And then, well, these species are showing different patterns of distribution, and this is also being part of the survival and perhaps also the local extinctions at least, and the population decline. And what I want to show here is a small case study. It is mentioned, you know, Euterpe precatoria, acai, is a symbol for the Amazon palm. And in terms of forest products, also this is an indicator of a very nice relationship with people as well. Not only because you can recognize a good condition of the forest, of the Amazon forest, but also a very important and very long period relationship with people. Please note that this species is being harvested between May and August every year. It is not fruiting the whole year, along the year, but still this peak of production is more or less well known in the Amazon. And this means for Bolivia the end of the raining season, but also the dry season. During the dry season, you can harvest these species. And you know, in Bolivia started the production of these species in order to decrease the harvest of the palm heart, which is killing the individual because it has a single stem. And it is mainly harvested by traditional ways, that is climbing. So the people is climbing and getting and cutting the whole infrotextans in order to process the pulp of those fruits in Cobija, which is in the north of Bolivia, and to sell and to trade these products locally, and it's not for export. Although I have learned that perhaps a part of this harvest is being commercialized with Brazil. And also, this product is a benefit for local people who has an income every year, but it's mixing the harvest of acai with the harvest of the Bertholletia excelsa, the castaña do Pará, that you know, or Brazilian castaña. And this is a balance for those communities. And also, it's not a low number of people that is involved. They are producing almost 6,000 kilos per hectare. But notice, please, that, oh, can I go, ooh, how can I go down? No, I don't know how to go back. Yeah. Please note that in 2023, it was 91 tons, and Last year, it was a record for the country, 132 tons produced. Forecasts before this mass production was telling us that in 2023, we were going to have a very big change in the season of Bolivia. And it was going to extend to the dry season to almost, during 3 years, for almost 7 months. So it was a forecast for 2030, and it's happening already before. And almost, yeah, ending. Ay, otra vez. Yeah, it has suffered a water shortage during this drought. So the producers reported that the fruits were falling down. They couldn't harvest them. They were in bad conditions. So the result was that they cut the production for 30% less. And the incomes for the people also declined. And then Peru, Bolivia are going to have this first ecological tipping point. You know, everything is connected. If Brazil is harvesting things here or over here, is affecting also other sites like Peru and Bolivia, because it's stopping the flying rivers of the tropical forest. And then it's going to be a catastrophic type tipping point because these 3 factors. So if we think about that this is going to be a point of no return, maybe almost 50% of these forests could be exposed to these disturbances and bad conditions. I hope it's not too late for this treasure, as Val said. Thank you very much.
Thank you, Monica. Fantastic talk. I would like to invite now Regina Rodriguez. Regina is an associate professor of physical oceanography and climate at the Federal University of Santa Catarina, with a PhD in physical oceanography from the University of Rhode Island. She is currently an author of IPCC AR7, member of the editorial board of Nature's Communication, Earth and Environment. She is a permanent member of the Brazilian Interministerial Committee for Climate Changes and chair of the subsection on climate disasters of Rede Clima. Her research interests include understanding how tropical ocean basins interact and affect the extratropics, leading to extreme events. Recently, she has focused on understanding compound extreme events over land and in the ocean. Welcome and thank you for being here.
Good afternoon. I would like to start by thanking the ABC, da Academia Brasileira de Ciência, pelo convite. E vocês podem ir passando se eu falar próximo? Sorry, I have to speak in English. It's just after lunch. So, okay, I would like to, so I'm going to start now. Next, please. I'm going to change complete gear here. We are not going to talk about forest anymore, and I'm going to talk a little bit about the ocean. That's what my expertise is. So the ocean, I would like to remind everybody that the ocean absorbs 89% of the excess heat from man-made climate change and 1/3 of the CO2 emissions. And the ocean provides us with a great service by doing that, but it actually pays a huge price. Next, please. So the oceans are becoming warmer, leading to more events of extreme temperature. We call them marine heat waves. Warmer waters lead to also less oxygen due to reduction in solubility in surface waters. And warmer waters also lead to a decrease in nutrients. Nutrient availability for microalgae to do photosynthesis, resulting in less primary productivity, which is the base of the food chain in the oceans, and also provide 50% of the oxygen that we breathe. And then the increase in CO2 on in parallel leads to ocean acidification, and this is really troublesome. Ocean warming combined with deoxygenation and acidification can negatively impact many species survival and growth, development, as well as shifts in community structure. A lack of food availability exacerbates this negative impact, so no wonder we have seen a decline in marine biodiversity, and I'm not mentioning even pollution like plastics and overfishing. Next, please. So, so what are we seeing here now? That there is also increasing extreme events of temperature. The red shades and the high acidity blue shades and low oxygen green shades in the global ocean. The left panel shows the spatial distribution of the mean intensity of these extremes at the ocean surface, and the top right panel shows the increase in the number of the days per year of temperature extremes or marine heat waves since 1860, and the bottom panel shows the same for the high concentration of H+, which is acidification, and you can see that we already have 365 days per year. Oxygen is saturated at the surface, so you won't see any of these extremes on surface, but next, please. So, but then I show here just briefly the same panels, but at depth of 200 meters in the ocean, and we can see extremes of low oxygen now in green in the left panel, and increasing the number of days per year of these extremes of not only low oxygen, but also temperature in the top right, and high acidity in the bottom right. So the occurrence of these extremes has increased not only in the surface, but also at depth. Next, please. So then we looking close at the tropical and South Atlantic, just to make it more regional here. We then analyze the extreme events individually of ocean warming, marine heat waves in left panels, low chlorophyll, and the middle panels, and high acidity in the right panels for the period from 1999 to 2018, when the three data sets overlap, unfortunately, just for this period, 2 decades. The top panels show the mean frequency for the first decade, and the bottom panels for the second decade. And we can see a widespread increase in occurrence of these extreme events, in particular for high acidity extremes. Next, please. And this is highlighted here by the difference between the 2 decades. So anything in red shades is an increase. So next, please. So now we analyze the number of times that they occurred simultaneously. Triple compound events of marine heat wave, low productivity and high acidity, left panel. Double compound of marine heat wave and low productivity in the middle panel, and the marine heat wave and high acidity, right panels. And in the tropical and South Atlantic, the frequency and intensity of these compound events have increased dramatically over the past 2 decades, peaking in most recent years, which put in check the capability of a marine ecosystem to recover from these compound extremes. Next, please. So this study estimates the impacts of marine heat waves alone, and concludes, and I'm going to quote her, right? Reported economic costs of individual marine heat wave events exceeded $800 million in direct loss, and more than 3.1 billion US dollar in the indirect loss of ecosystem service for multiple years. I mean, I don't want you to understand all the graphics, but that's what the estimates are. Next, please. So, and in this other study, the authors evaluated the impact of marine heat waves on coastal foundation species such as macroalgae, seagrass, and corals. This map illustrates the occurrence of a bleaching in hard corals and mass mortality events in soft corals following marine heat waves in different marine ecoregions. Most of the warm water corals have been affected by bleaching, with regions in dark red representing severe bleaching, mainly in the Indian Ocean and Indo-Pacific basin. And by contrast, actually, in ecoregion 21, I don't know if you can see, obviously, probably not, is the northeast of Brazil, are considered actually more resilient to warming with little bleaching in light yellow, but it's an exception. And has, we know now that it has been suffering bleaching since 2020. Next, please. So, as you almost know, and Artash, I think, mentioned yesterday, the Global Tipping Point Report 2029 that was authored by 160 scientists from 23 countries and was launched last week. This figure is extracted from them and from this report on the right, and shows parts of the Earth system identified as featuring tipping points. The report warns the world. The world is on the brink of reaching several tipping points, including the dieback of the Amazon, as we've been hearing, the collapse of major ocean currents, and the loss of ice sheets. And when we talk about tipping points, particularly here in Brazil, the focus is obviously on the Amazon, but the closest tipping point is the warm water corals, represented by the letter A in this figure all around the tropical ocean. Next, please. And here I show this article published in The Guardian, highlighted the findings of this report, and I quoted, "Planet's first catastrophic climate tipping point reached," reporter says, "with coral reefs facing widespread dieback. Unless global heating is reduced to 1.2 degrees as fast as possible, warm water corals reefs will not remain at any meaningful scale." And here I would like to link these three tipping elements that are of interest. AMOC, which I'm going to explain what it is, but it's also related to the ocean circulation, Amazon, and the corals. Next, please. So let's start with the Atlantic Meridional Overturning Circulation, or also known as AMOC. AMOC is a complex system of ocean currents that can be understood simply as a conveyor belt of heat, in which heat from the South Atlantic is transported to the North Atlantic and the Arctic by surface currents. In that schematic, they are in red. Among many other implications, as an AMOC slowdown or collapse would accumulate heat in the tropical South Atlantic. Next, please. So the direct impact of this, the effect of an AMOC collapse or slowdown would lead to more marine heat waves in the tropical Atlantic and more episodes of coral bleaching there. These regions, as I said, is one of the ones that are more resilient to warming compared to other ocean basins. But then if we start having even more accelerated warming, we might lose that too. And I want to point that in the tropical ocean, there is no other species adapted to living in such warm waters. So once we lose them, there is, and they are gone, there is no replacement for species in a tropical ocean. Next, please. And I want to say that AMOC can also influence climate over land and impact the Amazon through changes in the sea surface temperature of the tropical Atlantic. The sea surface temperatures in the tropical Atlantic, showing colors in these two panels, control the position of the band of intense precipitation, which is the solid contours, I'm not too sure if you can see it, known as Intertropical Convergence Zone, which brings rain to the Amazon. In essence, the ITCZ lies over the warm waters in the ocean. So this is easy to see with their seasonal cycle. During the austral summer, which is the top panel, the waters are warmer in the tropical South Atlantic, causing the ITCZ to shift further south and bring rain to the southern Amazon basin. Conversely, during boreal summer, bottom panel, the waters are warmer in the tropical North Atlantic, shifting the ITCZ further north, resulting in rain for the northern Amazon basin. Next, please. So there is a tug of war in the tropical Atlantic between the overall effect of climate change and that linked to AMOC slowdown or collapse. Remember, AMOC slowdown would lead to increase the heat in the tropical South Atlantic, making the austral summer state more likely in the future. Climate change, in general, tends to warm the northern hemisphere more, increasing the likelihood of a boreal summer state. Next, please. And so this is what we're seeing in this study that shows these figures, some climate models projections, and they showed that for the end of the century, the top panels are precipitation, bottom panels temperature. Left panel would be the effect of climate change alone for a pessimistic scenario, and the right panels are AMOC collapse effect. So AMOC collapse would alleviate the impact of climate change over the Amazon just a bit in terms of a temperature. I don't know if you can see, but the climate change would be warming of 10 degrees, and the cooling brought by possible AMOC collapse would be around 2 only cooling, so wouldn't actually compensate. But the problem is in terms of a precipitation, particularly in the northern Amazon, which is to have a drying signal. And this region, as most of you probably know, are most vulnerable to change because they are the most pristine part of the Amazon and are not adapted to change. Next, please. This figure shows vegetation regime shift. The next, please. And indeed, this study shows from paleoclimate data confirmed that during periods of weaker AMOC, the northern Amazon suffers more, which is the reddish, is the loss of cover. Next, please. So, and this figure shows vegetation regime shifts in future scenarios for global warming, left panels, and global warming plus AMOC collapse, the right panels. And if you just look at the red shades, which indicate negative shifts in regime from forest, meaning a transition to either savanna-like or bistable states, we can see that with the AMOC, it just alleviates a little bit, is almost like a postponing the negative change by approximately 10 years, given current rates of global warming. I mean, you can see like for only climate change 2014 is similar to climate change plus AMOC for 2015 and so forth, so on. But in summary, we needed to understand changes in the ocean to understand what's going to happen to Amazon. Next, please. So, and also Artacho mentioned yesterday the overshoot problem that stems from cumulative emissions. And basically, even if net zero, we reach net zero now, we will overshoot the global mean temperature, which we call the transient phase, before reaching the Paris Agreement target of 1.5, which would be the stabilization phase. And it could be as bad as passing 3 degrees. And the problem is that many tipping points can be crossed in this transient phase, including the Amazon forest. And in the heart of this overshooting is the ocean huge heat capacity, which has been absorbing all this heat. 90%, as I said in my first slide, and serving as a carbon sink, 30% of the absorption of CO2. Next, please. And just my final considerations. Unfortunately, recent research has shown that there has been an increase in the surface ocean thermal inertia. Let me unpack this for you by quoting the authors. There has been an increase on occurrence of marine heat waves and associated heightening thermal threats to marine organisms. And this study shows or suggests that the ocean ability to sequester heat is weakening. Next, please. And as a consequence, already found a record sea surface temperature jump in 2023 to 2024. And in the bottom right panel, you can all see how unprecedented this jump was in comparison to other years since 1979. And next. And unfortunately, even more, this was followed by a decline in ocean carbon sink. And my last slide. Next, please. So in summary, we need a healthy ocean to preserve not only marine, but also land ecosystems. The Amazon tipping point depends on ocean conditions and change. And therefore, we needed to understand how oceans will change in order to estimate the thresholds for Amazon tipping point. We need to fund ocean science, particularly ocean observations. The funding has been relentless cut worldwide since the financial crisis, particularly for ocean observations. So this is really, really worrying. And that's it for me. Thanks. Next, please. If you want to reach me.
Fantastic, Regine. Thank you very much. Well, our next speaker is Liu Boying. Liu is Associate Professor at the Institutes of Science and Development, Chinese Academy of Sciences, holds a PhD from the University of Leeds, UK. His main research direction is disaster risk assessment and management under regional sustainable development. Specifically, his research focuses on three aspects: comprehensive disaster risk scenario, simulation in complex system, design of coordination mechanisms among multiple stakeholders for risk regulation under compound disasters, and policy research on regional sustainable development from the perspective of a resilient society. Thank you for joining us, and the floor is yours.
Thanks for the introduction. I'm very honored to be standing here to show my research. According to the introduction, my research mainly focuses on the risk of natural disaster, especially for the urban flooding. During the past 20 years, I have been in this area nearly 20 years. In my first 10 years, I mainly do some more risk assessment models to assess the risk maybe probably happening. In present 10 years, I became a counseling to propose some more targeted measures to control the risk for the government. During the past 20 years research, I found that climate change has become the biggest uncertainty in this research area. And maybe in the future, climate change could be changing the whole research area into a new area. Due to the climate change, the intensity and the frequency of the rainfall has been changing frequently. Take China as an example. In my memory, I don't remember Beijing in this season could have a rainfall. But before I come here today, the rainfall has been in Beijing last nearly 2 weeks. So this change has made the traditional method we used has become unapplicable. Like we always use some historical data to calculate the possible risk in the future. But the climate change makes the historical data is not applicable, and we cannot to propose some more targeted measures to control the risk. Even what situation could be some more useful measures could become useless due to the climate change. So today I try to do this presentation about the changing pattern of urban flood risk and the impact of climate change. Here is a simple background. As we all know, under the influence of the climate change, the frequency and the intensity of urban flooding caused by the rainfall has noticeable increase around the world. It caused huge loss. But when our team tried to sort the data of the urban flooding, we found an interesting issue. In the first 10 years of the 21st century, the reported urban flooding risk, urban flooding issues mainly happened in the low and medium income countries. Few report from the high income countries. But after 2010, frequenting extreme events caused by climate change become globally, and the report from the flooding report from the high income countries has become more than the low and medium income countries. So we're trying to explain the reason from the scientific area. We collect data from the 138 capital cities from all over the world. We divided the capital cities in two kinds. The first is high-income countries. The second is the cities in low and medium-income countries. We also collect the data from the rainfall, and we set the two scenarios. The first scenario is rainfall and the 10-year return period. It means normal rainfall we have met every, we should to face. And the second is under 100-year return period rainfall event. It represents the extreme rainfall event. So we try to simulation each cities in these two scenarios to find the induction ratio in different scenarios. Here is the result of the simulation result about the 10-year return period rainfall event. In this picture, the purple point it means high-income countries. The yellow it means the low and the medium-income countries. The dot it becomes the size of the bigger of the size of the dot. It means the ratio is become seriously. Under the 10-year return period event, we can see the yellow dot is much bigger than the purple. So it's in the 10-year return period. It means the induction ratio of the capital of low and medium countries is higher than that of the high-income countries. The average induction ratio reached nearly more than 6% of the low and medium country cities, compared to only 2.9 for the high-income country capitals. So there is a significant correlation between the induction ratio and the economic development rate. Indicate that the economic income increase, the induction usually decreases significantly. But when we try to do the simulation in the 100-year return period rainfall event, the dot size, the two kinds of the dot, the size become the same. It means under the 10-year return period rainfall event, the induction ratio for the capital of countries at different economic levels, or both at high levels, which average induction of nearly 7 for the high-income country capitals and more than 10 for the low and medium-income countries. So the correlation between the induction ratio and the economic development level is no longer significant. So it means in the increase in the economic during a 100-year return period rainfall event will not lead to a reduction in the induction ratio. Here we try to make some more summarize in the distribution of the urban flood. In the 10-year return period rainfall, high-income countries are already can manage to regular heavy rainfall, and their capacity to do so is growing as their economic increase. The low and medium income countries struggle to handle the regular heavy rainfall due to their low economic income, regulatory great impact. And to the 100-year return period rainfall, when the rainfall reach a high level, like the 100-year return period stand, the influence of the economic income on to enhance the drawing capacity become less pronounced. At this point, all countries, no matter what the economic level, face a relative situation during the extreme rainfall event. So it's also raised a new question. If the economic level cannot change the risk situation, what the factor could be useful in the future? Here we chose the three factors. The first is the green infrastructure. It means the purple network, drawing purple solutions, like human-made technologies. The second factor is the green infrastructure. It's a natural-based, like the green space something. And the third one is the terrain. The elevation and the slope of the also can influence the flow of the water on the surface. So we chose the three factors to test which factor will become important in the future due to copy the climate change. Here is the result about the green infrastructure is the human-made technologies. The purple bar show the green infrastructure conditions in the high economic countries. The yellow is to show the low and media countries' capitals. The level of the green infrastructure constructions is closely associated with the economic level. The drainage network in high-income country capitals is nearly 14 times that of the middle and low-income countries. And the difference in the role of green infrastructure at the different rainfall levels is also obviously. The density of the drain network is negatively correlated with the induction ratio at both when the rainfall level below to the 200 millimeter one day. When the rainfall level is above 200 millimeter, the correlation between the density of the drain network and the induction ratio is not significant. So it means human-made technologies can only to handle the regular rainfall. When the rainfall to exceeding the 200 millimeters one day, it becomes useless. Here is the result about the green space. It's a natural-based solutions. According to our result, the green space conditions in the high-income countries and the medium and low-income countries are basically same. The presence of the green space is not closely tied of the economic development levels. As the intensity of the rainfall increase, the magnitude benefits of the increasing the proportion of green space become increasingly pronounced. When the rainfall rises to the 200 millimeters or above, the drainage contribution of the green space is becoming largest and even become a more important factor to control the huge rainfall situation. The third one is the contribution of the terrain. There is no correlations between territorial relief and the economic development in capital cities. But an interesting issue is maybe because of the historical reasons, the high-income countries' capitals always lead to the area created by low ground slopes, and the low and medium income always correct in the high ground slopes. So there is also no significant relationship between the relief and the industrial ratio at a relatively low rainfall level of less than 100 millimeters one day. But when the rainfall rises to the more than 100 and even greater than 200 millimeters one day, there is significant negative correlation between the relief and the induction. And the role of the relief becomes increasingly significant as the intensity of the rainfall increases. So we try to summarize these three points together. And 10-year return period, the rainfall scenarios, the drainage network, and the human-made technologies is the primary factors to influence the induction ratio in high-income capitals. When the rainfall intensity increases to the 100-year return period, its impact on the induction ratio becomes to decline. In the scenario of the 10-year return period rainfall, the green space to the induction ratio in the capital cities of high-income countries is limited. But when the rainfall intensity increases to the 100-year return period level, the calculation of green space becomes the largest factor. So the green space can play an important role into cultivate the intense extreme rainfall. So in the case of the middle and low-income countries, the very important value of green space and the green infrastructure also not obviously also a low contribution. That is in the case where the drain network is relatively complicated, the role of the green space is more pronounced due to the limited green infrastructure such as drain network. The relief is also the main relief has become the main factor to affecting the flood drainage. Here we're trying to analyze the mechanism behind the risk issue. So we try to draw the curve from the four scenarios. It's about for the high income countries and the low income countries, and which without the drain network or with the drain network, it can show the green infrastructure supported by the economic foundations in high-income cities could effectively cope with the normal rainfall, but it's useless to dealing with the extreme rainfall event. When the rainfall is lower than maximum drainage capacity of the green infrastructure, like the design stand, as the rainfall increases, the drain volume of the green infrastructure also increases. And the drain is mainly complicated by the green infrastructure. Once the rainfall exceeds the capacity, the green infrastructure reaches their solution. The excess rainfall is discharged by the green infrastructure, such as green space. Before the inflation capacity of green space reaches solution, the proportion of the rainfall discharged by green space to be the total rainfall keeps increasing as the rainfall volume grows. Last, maybe some more discussion. Under the intensify the extreme rainfall scenarios, the high-capacity green infrastructure drain systems created by of the high-income countries are gradually lost their dominant role to control the urban flooding, especially for when we try to upgrade the green infrastructure, is always needed to lots of investment. Most countries and most cities cannot afford this investment. So based on this situation, the natural-based solutions, such as to utilize the topography and enhance the green space, can be regarded as a pathway for the countries to strengthen the resistance capacity against the urban flooding in the future urban grids. Okay, that's all. Thanks.
You can have a seat. I would like to invite Tasso, Monica, and Regina to have a seat. And because of the timing, I will open for just 3 questions, quick questions. Please.
Well, I want to thank the 4 of you for the talks. I learned a lot again. I'm learning. And I have 2 questions. One for Tasso. You mentioned that you are now moving towards a partnership with other countries. And regarding and this connects with Regina, with oceans. How much of your map do you map also the oceans? And how much do they agree with other maps that are doing the volume of oceans? And the countries that would like to collaborate with map biomas, how they can access. And for Regina was very, I got really concerned. I'm a concerned person, and now I'm much more concerned. And do you have any data also regarding the increase in the volume and how it's going to affect the projections for people living in the seashore and small islands? And thank you again.
Thank you, Elena. One more here, please. Here. Yeah.
Okay. Thank you. Very nice presentations. And I'd like to ask Tasso. Tasso, I think map bioma is a fantastic example of what you call open science. Very generous work of a group of people, very well trained, with sophisticated technology, that develop one thing that is not for them to use, is to make this public and to make this. I'd like you to comment more about this experience, in general, our scientific community is very egoistic in terms of data control and things. How map bioma and the group in map bioma see that, and how the concept of open science that work, And Dr. Liu, I think a very interesting presentation, because you have some data from Brazil that this happened, that or say, but yet the disaster are very much associated with areas where there is high level of human segregation and inequalities inside small areas in Brazil, that are the municipalities in Brazil, where there is a more inequality. It's not only a question of rich world and poor world. Inside a country like this, the inequality is a really strong point, that allocate the population that will be suffer more with the disasters, in terms of human life, death, and the other things. Then if you could comment about that, about the component of inequalities, I appreciate very much. Okay, thank you.
Thank you. Well,
thank you. Thank you all for your presentations, but I would like to make a very short question to Professor Tasso. This is a very impressive presentation. I mean, I wonder how many countries in the world have such a system. I mean, the resolution that you have is really amazing, and I am very happy that you started working with Mexico. Hopefully, we will have something similar to what you have in Brazil very soon. But my second question is, can we access your system? How can we access your system?
Yes, that's what again, I'm sorry, I'm going to ask for you. In what ways are the data generated by map biomas being used to support evidence-based policy making for environmental conservation and sustainable land management here in Brazil?
Well, congratulations for all great lectures. And my question is for Professor Liu. Your contemporary, there is an architect that recently passed away. He talked about sponge cities, and your work, it's beautiful, shows in data how we should move our cities to be natural sponge cities. So I would like you, if you pick up the question of my predecessor, that here in Brazil, not only, but we have these too high inequalities, social inequalities. So how do you think about this kind of model of sponge cities to build? Is not an engineering problem, it's a biggest problem that green buildings should be used, but how do you see with this kind of inequality highest that we have here? Not only here, but of course. Thank you.
Our last question there.
Thank you. Thank you for the presentations. I am Cinderella from Suriname. I used to work at the forestry office in Suriname, and the forest cover monitoring unit, where we also mapped deforestation and land use land cover maps. And so at some point, we had to submit or deliver the results of our maps to the politicians so they can use it for international reporting. But then we also had an NGO that used data from Global Forest Watch and delivered another number for the forest and also the deforestation results. So at some point, the policymakers didn't know who to believe, whose data is the best or not. So I was wondering if Brazil also deal with this problem, and how did you deal with it?
Thank you very much. So I ask from Liu on to Tasso to quick answer and do the final comments.
It's a difficult question. Okay, it's a difficult question to answer because not in Brazil, it's in China, it faces the same situation. In the Western China, it's always dry every year. But from about 5 years ago, it become wet and the rainfall become more and more stronger. So our government and I and the Chinese scientists, we try to, according to their situation, to make for each city, for each target measures. So it should be different target and for different cities. Become of the local situation. So I count to make a target measure for each city. I think for these cities, we should to, firstly, we should to not only just the people working in life sciences or people just working in natural disaster to do this issue. It's needed to collaborate with different subject people together to make the solutions. And secondly, I think the most important is to propose some solution for the government. The government needed to do some support measures. So it's, I think that's all. Thank you.
Thank you. Monica? Your final remarks, though.
Okay, my final remarks are that despite we have these forecasts for many years later, we are noticing that things are happening before, and that makes us to take actions as fast as we can. Because, natural products are used by people, and it's urgent to take actions.
Thank you, Monica. Regina, please.
Yeah, I'm gonna just, I think it's just one question from Elena, and it's about projections of sea level, right? Which I didn't touch on this subject. But half of the increase in sea level rise is due to thermal expansion. So it's actually due to heating, and another half, more or less, is the melting of the glaciers. And the problem with these two components that is different from the forest, where, let's say, deforestation, you can stop if you want, and any time. But once in the ocean, this heat is on, the inertia of the system and cryosphere, particularly the West Antarctic, East Antarctic ice sheets, if they started, it's just a really difficult thing to stop. So that's where the precautionary principle is very important. So for us that work with ocean cryosphere, is much more difficult to handle. And this is going to have a huge impact on the coastal cities, no doubt. We don't know. Brazil, to be honest, we don't still have the research. We are asked this all the time, and you ask me, and I can't tell how many meters the science is behind on this aspect. And just the link with the observations is really harder to measure the ocean from satellite, for instance, globally, because you can only get pictures of the surface, and there's a lot of things that works underneath and satellites don't work. So the collection of data in oceans is very expensive, and as I said in my last kind of thought here, is that this has been cut a lot, the observations in the oceans, and they are really important for forecasts. They are simulated in the Copernicus Era 5, which are used by the new AI tools of a prediction, that they are so like, oh, we are doing better predictions than the science centers, but actually is all fed by Era 5 from Copernicus. They actually depend heavily in ocean observations that has been cut. The effect of this we haven't seen yet, but we will see in the next years. So I think for the Academy of Science, this is something that is not flagging, and we need it to really be, because the situation is really daring for ocean observations. Robotics will not do the job also, which is also, so that's my final statement.
Thank you, Regina.
Ocean. Ocean is a problem. No, the thing about ocean is that, so the only things we include, let's say, we include coastal area, and then we have mangroves and everything that is in coastal area, and we have kind of a beta version of the coral reefs in the case of Brazil, and we're thinking about the other regions also to do it. But the main reason is, first, water. It's something that in remote sensing is basically water. Like, you can do much more than that. I mean, you can do some things like different shape, but in general, that's what you see. Like, the most important and interesting aspect is that it's very difficult to geo-reference image in the ocean, because you need to have a point to fix and say, okay, this is the real place. So that's the reason why most of the sensors, they don't actually map the ocean, like like Landsat, and I mean, they do when it's in the coast, just because the image is in the coast. But in the beginning, when they start in 85 and 90, they had to save memory. So one of the ways to save memory is to not actually capture images on the ocean, and then it will be like something like that. So yeah, so unfortunately it's not included. I think there is other sensors that are different to work on the oceans that will be there. So that's why we say land cover, land use, not yet land cover, land use, and oceans. So how to participate? First, we always use Landsat because that's the one that you have the largest time series, and it's free and it's available globally. And we are very proud that this is free, mostly because of the policy of INPE in the 2000s in Brazil that actually turned into something that make it open. Also the catalog of Landsat is available not just in USGS, but is also available in several other servers. So we can use this, like in our particular case, we use this inside Google Earth Engine. So virtually any country can have exactly the same resolution. The problem is that there are some regions where you don't have information, good information, before the year 2000. That's related to the receptions and etc. But every country in the planet has, at least from 2000 on, you will have Landsat images every 17 days. So you can use this to kind of make this type of exercise. So how it works for a country to get in. So normally it's like somebody, like today, I was just here in the meeting and there was somebody from Australia that just sent an email saying, oh, can you actually present mapiomas to the university here? So it starts like this. Somebody asks us to talk and then we present and then a group in that specific country will say, oh, we are interested to develop something, and then they develop. So we don't do anything outside Brazil. For example, in Suriname, it starts because I met someone from an organization called Mulokot in one event, and they just joined with people from the university, and then they set up an initiative, and then we are starting to work on Suriname. So that's, for example, Kenya will start with young people that were doing their research, and they decide to do this thing, so we are helping them give the training. What we offer is the infrastructure, because we create all the infrastructure is on the cloud, and everybody works on the same infrastructure. So you can actually see the codes of other people working. You can kind of borrow everything inside of the platform. We use the same space. We have like 1.5 petabytes of data in this common space and so on. The thing about like how to access, like mapiomas.org, and you have like the access of all the country platforms and etc. It's so everything I show you here, it's in the platform. So like you can navigate on the maps. You can also download anything. You can have you have tools to make analysis of the data online also, and we also give the GitHub, which has all the codes that we use to process the data and to build the website. And something that we are very proud this year is that we launch a platform of platforms. So you can actually, if you like what you see on the platform, you can actually copy the platform and embed in your website. And then you can change the logo, include your data, and then you have the same features you have in the platform of Mapiomas you can have on your own website without having to make a server, etc., or pay Esri tons of money. So the thing about open science is, normally when people ask me, why you do this in networks in this way, since I'm not from this kind of I'm more a practitioner than a scientist, I would say, because I don't know how to do it another way. I mean, it's so difficult to do this kind of a problem that is very complex and high in size. It's not possible to do in a specific group and small. You can't move fast. So my desire is to move very fast with everything we do. And the way you can do fast is like by assembling tons of people to work together. Now, one decision that we took on the beginning is actually the key for having the open science. We decide from the beginning, with everybody involved, that we will publish the data before we publish any paper. That's the key element. So every time we finish a collection of maps, we publish first the collection, the data is available for everyone to work, and then we will make our paper, whenever. So that's why we have only 29 papers in Mapiomas, and there is 4,500 with other people. But the interesting, and I think that's the indicator that I think will matter for most of you that are dedicating your lives for the publication and so on, and to advance the science is, for the people, there are, especially from universities in Mapiomas, all of them has the same experience. Nothing that they did before in their career result in more publications, more reference, more people interested and use the data than what they did in Mapiomas. Because once you put the data out and you don't like wait for your paper, your data is always up to date. Like it's always the last thing on the room for anybody to use. And you know, the cycles of making the publication takes a long time. And also the other thing that's like just an experience is, once you have a data that you publish after you have a paper, it kind of creates a kind of, because of the ethics of the science, it creates a kind of a constraint. Like you should not use the data for doing something similar because that's the data from somebody else. And so the idea is like, no, you just leave the data. Nobody's making like its own of the data. So it kind of incentivizes more people to create things, you know, out of the blue from what they want to do, which I think it's a, yeah, it's a great thing. There is a lot of use on public policy. We start to register in 5 years ago, like different types of uses, and we stop on 500. So, like for example, IBAMA use the environmental agency in Brazil, use that for the licensing process. So you receive the report from the impact assessment report, and then you want to check how you validate an impact assessment report that said that there will be deforestation or not. How you do it? Or you do the study again, or you just use some other information. Okay, so you have the information to use, and you can do it. All the way to the banks in Brazil, they use, most of the banks in Brazil check one of our systems to check if there is recent deforestation, if it's legal or illegal, etc., before they give credit. People studying, Fundação Oswaldo Cruz, they have this whole thing for yellow fever, and that's one of the craziest things for us is like they use this to check whether you have monkeys on the regions, because the monkeys are an indicator of yellow fever, right? Like normally you have the yellow fever on the monkeys first. I don't know, I'm talking about something I don't understand, but if I understand correctly, if a monkey is dead and you check if they have yellow fever. If they have yellow fever, then you have to vaccinate people around, right? But if you are in a region that there's no monkeys, and there is another region there close by that had the monkeys with yellow fever, it's better to also vaccinate the other communities. It's an interesting way of using. There's the same thing for this garimpos, no? To check the garimpos area. Yeah, tons of potential applications that are there for whoever wants to use. And last, to say, I don't think we have to really worry about like what the people are doing with the data or what they choose to use. But like we just release the data and you can use, if you think it's useful, you can use. But there's two things we learn that helps people to use your data on a good way. First is that principle, release the data as soon as you get, because then you have the latest data available for the people to use and they will use. Right? The second is use this concept of always improving. One of the problems with data sets is that you publish the data set and then this data set is fixed. You can't change because it was in the paper somewhere, blah, 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 you can't change. No, you change, make another data set, make another version, make available. And so people had the tendency to think, oh, if I want to have the latest, I go to this place here where you have the latest. But the most important is the platform. Like people will access the data where it's easy, where they can actually get to the real data, not like just a print of something, that they don't get a PDF, they don't get they get the real data, like the raster file, the shape file, all the database, all the codes. If you get this right and very easy to use, people will choose to use what you're doing. And lately, last is the following. I don't remember any land use data set that was done globally that is actually used locally. If you find out one example, tell me, because I'm always trying to find out. It's basically when you look at the global maps, they don't understand the local reality. They don't match. As you get closer, you think, oh, this is strange. It's not like actually so you put the lenses out again so you can see the global data set, which makes sense. And it's important to have global data sets. But in order to have influence on things that are happening on the ground, it's important to get the knowledge, the sensibility, and the sense of what is important, which is done locally. And this will be the local researchers and et cetera that will know what is important. And so I think that's the breaking point. If you have, and that's why in Mapiomas we don't do maps outside our countries. Like if there is maps in Suriname, this will be done by Suriname people. If there is maps in Congo now, they will be done by the Congolese.
Me informaram que você tem um voo agora. Tem alguém te esperando lá para te levar. Muito obrigado. Uma foto. I would like to invite you all to be in the front, but before that, just join me sharing these people. Thank you very much for all the panelists. Please join here for the picture. Hey, Tasso, please. Group photo. Tasso,
Okay, let me invite those outside to come in the room so that we can start the last session. The last session of the day will be a thematic session from insights to action, justice and sustainability in the climate crisis. And I have the honor to invite Patrícia Bosa from the board of the Brazilian Academy of Sciences to coordinate the session.
So good afternoon, welcome to our last section of the day. It's been a quite intense and productive day of discussion, and we have a very good last section. And as have been already touched upon, climate crisis hits especially the vulnerable groups. Inequitable access to climate change mitigation and adaptation strategies can exacerbate existing vulnerabilities and enhance disparities. So we have a great group of panelists to discuss justice and sustainability in the climate crisis. So our last speaker, our first speaker of the section is Mauricio Barreto. Mauricio did his training in medical and his medical degree at the Federal University of Bahia, and then he earned a PhD in epidemiology from the London School of Hygiene and Tropical Medicine. Mauricio has served as professor of epidemiology at the Federal University of Bahia in the northeast part of Brazil, where he established the Institute of Collective Health. Later, he joined the Fiocruz Bahia as senior research and founded the Center for Data and Knowledge Integration for Health, CDAX, where he's having a great role in large-scale data analysis to inform public health policies. His group has made a very important contribution during the pandemics. Mauricio Barreto is a member of the Brazilian Academy of Science and of TUAS. Thank you, Mauricio.
Well, I'm from the health section of the academy, then certainly my topic will be on health, yeah, and health science, yeah. There was some problem. Well, I would like to start with things that everyone knows, yeah, that there is a huge change in terms of the climate is really changing everywhere. And the impact have been noted, have been impressive, and increase each day, as I showed in previous presentation. And certainly all these factors have huge impact on health. I think this is an important point, yeah, in terms of lives, yeah, that are cut by the effect of these different signs of the climate change, yeah, and diseases and the effects on the infrastructure of the health system. Yeah, then there is a huge interest, yeah, for international organization, yeah, and institution, academics, yeah, start to grow the interest to study the effects of climate change on health, yeah, and these effects is in different areas, as I said, yeah, because in general, people think only infectious disease, but not true, yeah. The climate change affects cardiovascular health, respiratory health, yeah, mental health, injuries, yeah, nutrition status. Yeah, there is a growing literature, yeah, that show different levels, yeah, and different areas of effects, yeah, as the expression of climate change. And climate change also aggravates health inequalities. I think it is a topic that was put in the past section, yeah, not only between countries, yeah, but inside countries, yeah, and in different populational groups, yeah, social groups, age groups, yeah, that are affected differently, yeah, by the signs of the climate change, yeah, children, old people, yeah, vulnerable population, yeah, different kind of vulnerabilities, yeah, and in an unequal society like us, yeah, this effect is very easy to note, yeah, the differential effect of the climate change. In a scientific perspective, yeah, this interest is growing. Yeah, you see here the amount of publication that is produced in the literature is increasing quickly. Yeah, very a sharp increase in the past few years. Yeah, this was given the interest of the community, the scientific community. Also, founders, yeah, of different founders increase, yeah, the amount of support, yeah, to research in the field of climate and health. Yeah, here also the similar things, yeah, as others, yeah, things. The distribution is very unequal, yeah, of this scientific production. You see, they are very much concentrated, yeah, in the north in relation to the south. Yeah, here is a search, yeah, to understand how climate change, because climate change is a concept, yeah, that have different expression, yeah, in terms of different effects, and go, yeah, or affect health through different pathways, yeah. Then it's a very complex phenomenon, yeah. It's not a single thing, yeah. As sometimes you're in a simple way, yeah, try to understand there's a unique mechanism, but in fact it's a complex mechanism, and that interact with different social and behavioral contextual factors, yeah, like inequality, social inequality, or other behavioral, yeah, aspects of the different societies. Yeah, this interest was growing in COP, yeah. The first COP don't have a discussion on health, yeah. In some moment it started to introduce a discussion on health, yeah. And in the COP30, was created the Health Day in the COP. Yeah, this was really the introduction or the acceptance of health as an important part of the COP, yeah, discussion. Then from the COP 28, 29, and 30, yeah, in Brazil, we have a Health Day that will be on the 13th of November. Who will be in COP, yeah. This will be the day dedicated to health. And one important point, yeah, is that this have been evolving, yeah, and in this process, yeah, was prepared what people have been calling the Belém Health Action Plan. Yeah, is a plan that tries to put forward, yeah, some ideas on the health action necessary, yeah, to cope with the climate change process. And I'm very shortly, yeah, the plan is based in two cross-cutting axes, yeah. That is health equity, yeah, that is an important point, the equity question, to create a leadership and governance in climate and health with social participation. Then I think social participation and equity is very central in this plan, yeah. And the plan have 3 lines of action, yeah. Surveillance and monitoring, yeah. I'm not presenting details, but the plan is now public, yeah, it's accessible, yeah. They will be discussing in COP and in an effort to approve this plan, yeah. The second line of action is evidence-based, to policy strategy and capacity building. There is a clear idea that is necessary to produce more evidence, to guide the action and the necessary policies, And the third point is innovation and production, That is related with the adaptation measures, capable to really mitigate or adapt to the process of climate change in course, Given that there is a clarity now that one of the there is two major effects, one on the population health directly, and the other on the health system, For example, in the last flood in Rio Grande do Sul, 400 health units were suffer effects for the flood that happened in the state. Well, only to start on Brazil, then I'm going to present now some efforts that my group is doing to understand the question in the Brazilian context, Brazil is a large country, everyone knows that, but with the Brazilian population is now over 200 million inhabitants, a very urban population, with 84% of the population is urban, is administered, through a small unity called municipalities, that have over 5,000 municipalities, have a high level of social inequality, despite the decrease that have happened in the past decades. Brazil is yet a very unequal country, and it's a large country with different and a wide range of weather conditions and biomes, and is housed, as is presented here, the Amazon, great part of the Amazon rainforest. Well, Brazil has a huge climate burden, in terms of as far as health is concerned, as I told you before, but there is documentation already that Brazil is suffering, a lot with the process of climate change. You have been extreme events, that were well documented, where a lot of life was lost, diseases or new events of disease happen, that make clear that the country start to make visible the effect of the climate change process. But to start that in terms of health perspective, I'm going to present efforts in the center that the CDAX, the Center of Data and Knowledge Integration for Health. Now, CDAX, in summary, is a center that we work with the national databases, Science, health science, you need data, a lot of data, that in routine, the scientists, the researchers collect this data to their own research. But in the health field, and there is a lot of data that is now produced, in the different, with the different objectives, a huge amount of data is produced. And it's not new, effort to use this data, to produce research. But you increase this when you got the different databases, and integrate these databases, because these databases are fragmented, they represent the mortality data here, the birth data here, the education data is here, the information on infectious disease is here. Then you have different silos that are not integrated. But if you want to integrate that, you need a huge effort, that you generically call data linkage, that effort to link this data to produce a mega structure of data, capable to answer complex investigation, complex research question, in some way mimetize what you do in the normal research process, Then with this data, the group in CDAX created among other things, 2 large cohorts. One cohort is the longitudinal studies. You follow group of the population over time. Is a basic method of investigation in population health, in epidemiology. And you create, but normally this cohort are created with data primarily collected by the researchers. What limit in terms of numbers, in general, a large cohort, you have a few thousand people, And with this data, you create a huge cohort. One is the 100 million Brazilian cohort, that in fact now have 143 million people in this cohort. And another thing is a birth cohort that so far have 28 million births. Then with this cohort, you have been studied different things. You don't start to study climate effect. You study a lot of different other things. And this cohort are housed in this center. That have a very powerful computational infrastructure, and a very complex data governance, because one of the big problems to work with this data is the privacy question, and require a very complex governance system, to give the data owners, the possibility to transfer this data, and this data be manipulated in our center in a very safe environment, capable to protect all the personnel identification and the other things, and all the privacy, necessary, to manipulate the data without any risk, to put or to characterize individual people. Well, with this data, you have been investigating different things. You have here some short notes. One thing is on inequality, on health inequalities. Have been a very central question in our research. I was talking with Ricardo about that. You have a lot of very interesting data. That is it's not possible to be produced with other alternative, and no other people have this. The data have not been known before. You have idea that it is exists, but you don't have quantify the magnitude of that. For example, here is the mortality. Well, how go back? Here's the mortality of the indigenous kids, compared with the other population, black kids and the other racial groups in Brazil. Here's the nutrition, in different ethnic groups in Brazil. A lot of other studies, in different groups work with different questions, explore, how much the social inequalities that exist in the country reflected in the health condition of the population. Another thing very important in the center is to evaluate the effect of social policies in health. There is a very much interest. Poverty is a huge determinant of health. Brazil have one of the biggest program to reduce poverty, that is the cash transfer program, that you call Bolsa Família, and you have shown, that Bolsa Família has a huge effect on health, in different health outcomes, HIV/AIDS, or infant mortality, or suicide, or maternal mortality, or birth weight, a lot of different outcomes, health condition, mental health, substance use, there is a huge transformation in the country, and that's possible to be explored with this data. Another point that I think will be important to the climate question is to investigate immigration. It's one of the few data in the country that you can explore, the question of immigration, internally to the country, not only external, but internal migration inside the country. Well, now recently you have joined to this system of data, climate data, was a grant from Wellcome Trust, to us, and that is making possible this process, And you have now a big group of meteorologists, climatologists, geographers, that are using different data that exists around, in Brazil, or in others, like Map Biomas, for example. You are a user of Map Bioma, but other data, to create a layer of data, of climate and environmental data, to integrate in our health analysis and make it possible to explore, over the time. You have data. Our cohort started in 20 in the early century, in the 2000 until 2002, 2003. Then you have more than 20 years of follow-up, Then you have climate data, for all this period, to integrate, into the cohorts. And this is making it possible, to explore a lot of the objective, is to integrate this health data with climate data, in a very responsible way, As I said, you have people with the expertise to operate with this data, This is not done by people who want to understand about climate, but are experts and people trained, to manipulate this data and to build the variables and to interpret, and to give it to us in the epidemiologists, economists that have been working with the health data, information to work associated with the climate data, A complex data integration system exists, that make it possible to integrate this data. As I said, the protection or privacy is very central in this process. Everything is done in a very sophisticated way, to protect the privacy, And then was created what you call the SIDAX Clima, a component of SIDAX that is dedicated to the analysis of climate. This is a project that involves ourselves, the London School of Hygiene and Tropical Medicine is one of our collaborators, There is a great interest from the Ministry of Health in this process, And now you start to have some results, that I can shortly present, Well, it's not so much. Then you have studied a lot of different things, are in process, these studies, a lot of these studies, some are submitted, some start to be published, but I only give a flavor, of kind of study that's possible. For example, study of the ambient temperature on non-accidental mortality in Brazil. With this data, it's possible to see not only cold-related as heat-related mortality, and you decompose it by subgroups of a population, In general, the climate study have not so easy to decompose that, given the structure of data that is used, and it's not possible. With our data, using data from the cohort, it's possible to see different ratio, different effects in different subgroup, population subgroup, as presented here. It's the same thing to the heat-related mortality, Some poor quality home people have a high risk, Indigenous have a higher risk, than older adults have an increased risk, And then this is one thing that you explore, is the unequal effect of the climate change. Another thing is to evaluate programs. One important thing is the attenuation of this effect. And for example, there is one very important program in Brazil, mainly in Northeast Brazil, in the semi-arid region of Brazil, that is the CISTAN program. And this CISTAN have been evaluated for different purposes. but now you want to understand how this work, yeah, during more drought periods, yeah, how this affected the health or have mitigate the effects of droughts, for example, in the population health. And you see here some effects, yeah. For example, the cisterns, yeah, the houses who have cisterns compared with that do not have less, oh God, have less overall children mortality, yeah, less mortality for diarrhea, yeah, less mortality for infection, parasitic disease in general, yeah. Then it's a really very important effect, yeah. Then now the next step is explore, yeah, how try to decompose the periods, yeah, in terms to see if the droughts, during the droughts, how much or how the magnitude of this effect are, yeah. Another line of study is to explore the effect of the Bolsa Familia to mitigate or to mitigate the effects of the climate change. Yeah. Then you see here that as I said before, yeah, Bolsa Familia have a huge effect, yeah, on the different health outcomes. But you see here that this effect is also higher, yeah, during the periods of droughts, yeah. Then probably they have a more protective effect, yeah, during the drought period, yeah. You have your other data here that show in this direction, yeah, for some outcomes like here is low birth weight. That is an indicator of a healthy pregnancy and a healthy children, yeah, is the level of weight at the birth of the child, yeah, and you'll see differential effects, yeah, given the Bolsa Familia. And the last thing, yeah, that I would like to show is another a complement of that is to explore a question that the climatologist has put forward. That is the question of the attribution. How the climate change, how the effect is attributable to the climate change process. This is requires more analysis, yeah, modeling system using the CMIP and the other models system. Some of you probably are familiar with that, yeah. And it have been possible, yeah, to explore, yeah, how in a scenario, yeah, with the anthropogenic effect, to compare with a scenario without the anthropogenic effect, yeah, and you see the excess of mortality, yeah. And so far, our result, for example, related to temperature, yeah, you have shown, yeah, that around 2/3 of the death linked to temperature, yeah, are due to the anthropogenic effect or the anthropogenic transformation in the country. Then this is a find that is under review, yeah, because it's a complex method and requires a lot of efforts, yeah, to do that. But it's a very interesting because you start to explore, yeah, the possibility to go in details, yeah, to study how much climate change really, the cause or the behind, yeah, the effect that we observe in health in an important outcome that is mortality related with temperature. And then only to final reflection, linking routine collect routine data, yeah, in large scale, yeah, climate, social, and health data, offer great potential for understanding population climate vulnerabilities, yeah, and explore in detail that can be informative, yeah, in terms of to understand what is happening in our social tissue, yeah, in our population in general. Yeah? And a lot of evidence have been generated regarding marginalized population, yeah, the effect of social policies, yeah, and also how migration, yeah, internal migration in the country are connected with the climate event that happen around. Okay, thank you very much.
Thank you very much for the great presentation. It's powerful data that you have managed. So our next speaker is Zuzu Baniwa. Zuzu Baniwa is an indigenous educator, researcher, and leader of the Baniwa people in the Alto Rio Negro indigenous territory. Zuzu has dedicated his career to strengthening indigenous education and integrating ancestral knowledge with scientific approaches to address environmental and social challenges. He holds a degree in intercultural physics from the Federal Institute of Amazonas and a master in environmental science education from the Federal University of Amazonas. He recently received the 2025 Bunge Foundation Award for his contributions to biodiversity conservation and the indigenous knowledge system. Thank you very much for coming.
Good afternoon, you all. As it was previously presented, I'm Zuzu Baniwa. I'm an indigenous person. I live in the Alto Rio Negro tribe. And it's the scientific community for giving me this opportunity and this invitation for being able to participate in this important moment where we got to a point where the world needs the collaboration of each sector, of each community. Beforehand, I would like to bring some local report about the climate change. Even though my people, my culture, we are not very evolved in this sense, but we are suffering with a systemic climate change. Indigenous people and climate urgencies, systemic impacts. I think this is a very important term because the world, there's no other worlds. So you can see that another world, there's this one, there's another one. The impact of the climate changes, they are coming to our territory in a systemic way. There's no way to say that this problem you will solve with scientific knowledge, and this other one you will solve with traditional knowledge or local knowledge. But that requires a collective effort for us to build a systemic learning way so we can respond to this impact that is coming to our territory. It's important to say that as indigenous people, we have our system of the knowledge, environmental knowledge, that is connected to the governance in our territory, the management of our world, our practices, a social economic management for our well-being. We have been building this learning, this process in the Amazon, in the territory for hundreds of years. Amazon is the result of this living. The Amazon is this result of our science. that is promoted in many events, rituals, cultural rituals, the living, the learning, and that from that we create this vision, this more systemic vision, not in the Cartesian plan, but connected to the territory, the cosmology, to this divinity in the forests, that we belong to nature. Nature doesn't belong to us. We live in the territory. Therefore, so going to the points, we are living in the lately some extreme events like droughts, floods, fires, the biodiversity loss, food insecurity, and my colleague said disease within the territory. And here the fire in the Rio Negro, the Negro River, that comes from the Amazon River, that comes in, is it specifically in the municipality of São Gabriel da Cachoeira, Santa Isabel. The main focus of the fire has been increasing significantly the last times. And we understand this as a period of drought. What we called summer. With the summer, the forest is drier, and then it's more vulnerable. Any touch of fire that spreads out and devastates the whole territory. These are data that we were writing in partnership with the Social Environmental Institute that are our partner, and also the indigenous organizations of the Rio Negro. In 2018, 2020, and 2023, we have in our records this increase of the vulnerability. The São Gabriel da Cachoeira, it's a municipality that it's small, and it depends on the supplies from Manaus with the extreme drought. The navigation became something vulnerable. So practically ferry boats that would supply the town, they just won't navigate. And we have this record of the price increase, as my colleague said, about the vulnerable society that only depends of government support for their income. In this case, they become very vulnerable. Here, for example, we register about 40 reais per kilo of fish. So this price in this period, they affect significantly the life of population. 40 reais is about $8. One important thing is that there in the territories, we are tracking or living in the forest. We see that the temperature is increasing, and this temperature is influencing the plants to bear fruits. And they bring direct impacts in the forest. And then other systems come out of this, like a food chain for rodents and for fish, which we directly depend to live in their territory as well. You got power plants. They are being affected as well. The absence of fruits in the forest possibly provoked other animals attacking our plants and our crops. Same thing happens with the fish when we talk about the fish chain. Low river, hot water, low oxygen, and we register height of fish killing. It was our case in the low Amazonas. Last year, we had a lot of it. Why is it important to talk about this? Because we depend directly from the fish. We depend this in our daily basis. When there's a big killing, this impacts our livelihoods. Here, it's what we hear, talking with the leaderships, that they are perceiving that this change, this impact in their territory. And here's some records that we also have: the extreme floods impacting directly the communities. This was a record that I've made in 2021 and 2024. This is a picture that it's very impressive, impacting, I would say. This green part, it's actually crops, but with the extreme flood, it actually flooded out all the whole crops. So the women, they are actually trying to save their manioc to produce their farinhas and other products. The same picture as they are leaving. Another situation. So, what catches our attention is that so before these climate changes that are occurring, that we need to work together. And I see here as a local, I live within the territory. There's no space like this, like INPA or other laboratories in there. To monitor through technologies like you all talked about, to do this precise tracking. But as I said, before we as indigenous people could participate in this building of monitoring, that we can participate in in spaces, in rooms like this, so we can try to find a solution, a collective solution, or creative for these challenges. We need together to think about a mitigation plan and a territory. We need investment. And there, when I talk about territory, it's an absence that they would call here in the city of a sewing system. There's a total absence. That's why we depend on the rivers, the tributaries, so we can pick up our water. For this thing, we need investment on basic sanitation so we can have access to quality water. Equality, social justice, they are always beautiful words to say, but they still find difficulties to reach those remote places. So the scientific community and the government, they have to build this dialogue so we can advance in the creative solutions. We've been recording this experience in this research, intercultural research, building with a partnership with the ISA, the social environmental institution where I am part of as a researcher, as an indigenous researcher, and these observations, we are actually creating papers so we can register what's going on in our territory. So we are in our 6th edition of our magazine, and each year we are accumulating experiences and registering it as well. So this is what I wanted to bring to you all. I thank you one more time for the invitation. And I want to say that I'm available to participate in other events, whether it's in Manaus or anywhere else where it's needed. Thank you very much.
Muito obrigada.
Thank
Sua
you
fala
very much.
foi essencial para essa reunião. Muito
Fundamental
obrigada.
for this meeting. Thank you.
So I'd like to present our last speaker in the session, Gabriela Giulio. Gabriela Giulio is an associated professor at the Department of Environmental Health at the School of Public Health at the University of São Paulo. She holds a PhD in environmental environment and society, and her research investigates how environmental crises affect social-cultural contexts, social practices, and decision-making process, particularly in the urban settings. She has been involved in inter- and transdisciplinary projects on climate governance, the science-society policy interface, and risk communication. She's a member of the São Paulo State Academy of Science, and she's been part of the steering group member of the Urban Prediction Project of the World Weather Research Program. So thank you, Gabriela.
Thanks, Patricia. Thanks for the invitation. It's a big honor and a very challenge to be here, to be very honest. When I was invited to this panel talking about justice and sustainability, I was thinking about how can I frame these things that, as my colleague Zuzu said, it's theoretical things that we are discussing in the academia, we are discussing in our meetings, but it's a challenge to put into practice. So I decided to bring some insights informed by our research based on cities, vulnerabilities, and we can discuss together the challenge that we have, particularly right now, that we are preparing, and we are very motivated for the COP in Belém. Okay. Yeah. Oh, yeah. So in the last 2 days, we talked a lot about how climate change is not only a phenomenon, a meteorological phenomenon, but must be seen as a condition of our time. And as a condition, I mean that it interferes, amplifies, accelerates all the contradictories that we have in our societies, like inequalities, poverty, disease, and I think that Mauricio said this, and I affirm this with a very concern, that this is the biggest challenge in terms of global health that we have to deal in this century. And despite of the fact that we are talking how we as scientists, scientific communities can contribute to COP30 or to deal with climate change, we know that climate agenda is shaped not only by scientific knowledge, the data that we produce, but is particularly shaped by political and social elements. And in the COP30, we are very concerned about if the main systems, if the main drivers of climate change are in fact considered by the governments, diplomats, and who are negotiating this process in terms of energy, food, financial assistance, particularly because we are living in a very difficult time in terms of crisis of multilateralism, the rise of the far right, and we see this kind of event as an event that political and symbolical contestation surely direct the negotiations, the decisions in terms of climate change, and we hope that the global South leadership with the BRICS assume a more consistent, robust, prominent role. But there are two specific issues in this COP30, and I think that they are very connected to my presentation, that I'd like to call our attention. The first of all is how to improve the adaptation agenda, how we can improve the what we calling sustainable adaptation. And the second is how to involve and engage different actors in this process, particularly to guarantee a multi-level governance and to understand the role of subnational governments and cities. The last World Cities report launched in the last year was quite clear in terms of the role of the cities in climate change. Cities are understood as a kind of hub for climate adaptation. And the climate change should be mainstreamed across the relevant sectors in terms of housing, sanitation, water, transportation, local food production. However, the urban efforts all over the world to tackle climate change are not reaching the necessary scale to address these challenges. And there is also a significant problem in terms of financing resilient urban infrastructure. At the same time, cities are projected to become hotter. Sea level rise and river inflows are big threats. Landslides are big threats. The climate crisis, as Mauricio mentioned in the first presentation in this panel, is very discriminatory. So the most vulnerable people are being affected by the impacts of climate change, and we know that this phenomenon, or this condition, intersect with other vulnerabilities. At the same time, we see that some climate interventions are accelerate this vulnerability. So again, and this report is quite clear in terms of the inadequate capacity of the cities to deal with climate change, and we have to pay attention in some institutional barriers that pose concrete obstacles to do something at the local sphere. Next slide, please. Yes. So I will bring some ideas about Brazil. So how Brazilian cities are dealing with climate change. In terms of a macro perspective, we can see that Brazil has very good regulatory frameworks regarding climate change. We launched in 2009 a national policy on climate change. We also have a national policy on civil protection, disaster risk reduction since 2012. Brazil is a signatory of the Paris Agreement. We also has a national adaptation plan, which was launched in 2016 and now is under review. But despite of these regulatory frameworks, we can say that Brazil has still a very conservative stance on climate issues, which is marked by inconsistent and uncoordinated responses over the past 2 decades. Brazil is still dependent of fossil fuels and now is putting resources, money in the pre-salt reserves. We can observe fluctuations in terms of deforestation control policies, a persistence of a sustainable agricultural practice. And in terms of the Brazilian municipalities, the adaptation strategies have been very slow, very limited, and in the end, Brazil is not prepared to cope with the impact of climate extreme events. All right, next slide, please. Okay, and I gave some numbers from this Digital Atlas of Disasters in Brazil. So in the last 3 decades, Brazil registered officially more than 5,000 deaths, more than 10 million people were displaced or homeless because of climate disasters, more than 1.75 million people have been injured or ill regarding the extreme events. More than 131 million people declare that they are directly affected by climate events. And in terms of material damages and losses, we also have very concerning numbers. Next, please. Okay. Mauricio also mentioned this. Brazil is a very urbanized country. More than 84% of the population live in cities. And of course, we are talking about different cities with different characteristics, like São Paulo with more than 12 million people, or Manaus with more than 2 million people, and it's very small cities with less than 10,000 people. But half of the population of Brazil live in urban centers with more than 100,000 people, which means that medium-sized big cities in terms of comparison with other cities all over the world. And over 33 families that are registered in CADE Único, which is this platform that the government have to identify low-income households that need to access some social programs. 30 million of these families live in urban households. And until 2003, so 2 years ago, more than 80 million people in Brazil declared that they were facing severe food and nutritional insecurity. So next, please. So when we are talking about climate change in Brazil particularly, but we can thinking about the reality in some African countries, in some Latin American countries, we need to consider what we call a perverse equation, which means that climate emergencies is only one another factor that amplifies, multiplies the effects of poverty, unequal access of education, income, and the natural resources. Next, please. Next again. So I brought this slide just to remind us that when we are asking for Brazilian cities, if they are doing something in terms of climate adaptation, in terms of climate governance, they said that they have many barriers in terms of municipalities to advance in this agenda. And we did this research involving 6 big cities in Brazil, including Manaus, where we are, São Paulo, where I am from, and we observed that, in fact, there are a combination of different aspects that can explain why cities have so many challenges to advance in this agenda. First of all, adaptation is a transversal, transsectoral agenda, and the cities still have disconnects between sectoral policies. There is a lack of clear responsibilities and priorities in terms of governmental responsibilities, proposals. There is still a bureaucratic mindset that means delays in formal procedures, especially in urgent events. There are many conflicts between different jurisdictions, between the federal, the state, the local levels, and also 3 important perspectives. There is still a prevalence of utilitarian political perspective, especially in small cities. Political interests are very hostile to environment and the climate agenda. There is a lot of influence, pressure from some groups, particularly the housing sector and the transport. So our research shows that there is a resistance to adaptation measures, and this increases if they involve land planning regulation, if they affect land values, if they cause economic impacts to public or private sector. And also there is insufficient informants or fiscalization of the governance of the regulations, frameworks, and the laws that exist in the cities. Next, please. So we asked what about the level of institutional adaptive capacities in cities? By adaptive capacity, we mean the conditions that cities have to do something in terms of climate change, the potential that cities have to adjust, adjust in different sectors, in different areas to be more prepared, more resilient to climate change. And by institutional adaptive capacity, we mean that we focus only on laws, public policies, and instruments that are municipalities' responsibility. So we developed this index, what we call Urban Adaptation Index, with 3 main goals: to systematize information on the existence or the lack of some public policies that we consider are important, and again, is the responsibility of the municipality to deal with climate change, to assess the current potential of cities to cope with the effects and the risk of climate change, to have a kind of portrait of the reality in Brazil, and to stimulate debate and encourage local governments to see this picture and to do something. And we designed this index based on literature review, data viability, the Brazilian context, and this index is composed by 5 dimensions, and we think that the potentiality of this use is not for the local governments, but also by regional and federal initiatives. So we presented this data to people who are responsible for the Adapta Brazil, which is a platform developed by the Ministry of Science and Technology to improve the adaptive capacity of the cities, and to the program Adapta Cidades, which is a new program of the Ministry of the Environment and Climate Change that focuses on the resilience of the cities, the Brazilian cities. Next, please. Oh, yeah. So this is the index. So again, 5 dimensions and 25 indicators. So we are have indicators in terms of housing, urban mobility, local food production, environmental management, and the climate risk response. And if you see, this is the very, very basic indicators. For example, in housing, we asked if a municipality have a municipal housing plan, if the municipality has a municipal council and a municipal funding. So if the problem is at stake, if they have funding to do something, and if the decision process is more or less participatory. In terms of climate risk response, we asked if the municipality has some public policy or law regarding land use and occupation related to flood prevention, to landslide prevention, if the municipality has a municipal plan risk reduction, a geotechnical chart of suitability for urbanization, which is a very important instrument in terms of urban planning, and if the municipality has a municipal civil defense. Again, very basic indicators, but all of them are quite related to the national plan of adaptation that we have in Brazil, and it's the responsibility of the municipalities. It's a very simple arithmetic. If the city said, I have this instrument, they score 1. If they say, I don't have this instrument or public policy, or I don't know if we have one, it is 0. And we got this information from the IBGE, from research that IBGE do in all municipalities in Brazil, 5,569 plus Distrito Federal, the Brazilian capital. And now I bring some results for you. Next slide, please. And Paulo mentioned before that map is power. So we believe this. We specialized all the data that we got from this index. We produced this these maps, and I can talk a little bit more of them. We have the percentages, we've produced graphics, but next, please. I'd like to call your attention for 2 maps. This is the first one. This is the index for the whole Brazil. Next, please. And some very concerning numbers. Only 1% of the Brazilian municipalities have a high score in the Y. 36%, only 1 in 3 municipalities declare that they have a municipal housing plans. Only 13% of the municipalities said that they have a municipal risk reduction plan. Only 5% that they have geotechnical maps. Only 7% said that they have some laws or instruments related to climate adaptation and mitigation. Next slide, please. And this is the most concerning map that we produce. It is about climate risk management. And you can see the red color. So only 4% of Brazilian municipalities score above 0.6 in the Y level. And 65% record a score below 0.2, which means that most of the Brazilian municipalities declare that they have only the civil defense. And we know how the civil defense in most of the municipalities works, with few people, with few resources, very unprepared, depending on the voluntary work. Next, please. And we add the lens of climate justice to this kind of research, and by climate justice, we mean that we need to recognize that social inequality is a key factor in defining not only the occurrence of disaster, but mainly the unequal ways in which people experience these disasters. So two perspectives that are very important in terms of the climate justice lens. Not all adaptations are led by the public sector, but the role of the political government, the local government in this process is critical to ensure that public policies can reduce the impacts of climate change, and these strategies benefit everyone, particularly the most vulnerable people. And the second perspective, which is very important in this lens, the existence of a policy or instrument does not guarantee its effectiveness, not address the complexities and inequalities present in the local territories. And when we add this lens to understand, for example, how Brasilia, which is one of the cities that scored very high in the Y, almost 1, and São Paulo, which is another very good in the portrait, how these levels can translate in the local territories. We combine the social, economic indicators, also environmental indicators. We can confirm that public policies show limited impact in the poorest neighborhoods in São Paulo and Brasília. Underserved areas in both cities tend to have a less green space, less green areas, which we know it's very important to mitigate the impacts of climate extremes, and also the underserved areas concentrate zones of higher hydrological risks like landslides and floods. So addressing social inequality is a key to enhance the city's ability to adapt to climate change. Next. And just to finish, I would like to call our attention to the reality of the Brazilian small municipalities, because most of the municipalities in Brazil have less than 50,000 inhabitants, which correspond to 88% of the total area of the national territory, 24% of the GDP, around 30% of the Brazilian population. And the most, as you can see, the most of the occurrences of disasters, 84% of the official disasters are concentrated in these municipalities. And also when we pay attention in the Y index, among the small cities with fewer than 50,000 inhabitants, the index, the final index, is between 0.3 and 0.4, which is very slow. And we need to clarify that we can interpret this data also with the lens of the lack of mandatory territorial planning, which is not municipalities with less than 20,000 inhabitants are not obligated to have this kind of territorial planning. So this can explain something that we observe in practice. Next, please. And there is another index. We didn't develop this, but we use it a lot, that tries to understand how Brazilian cities are dealing in terms of the Agenda 2030, in terms of the 70 Sustainable Development Goals. And again, if we have a look at the small-sized municipalities, most of the cities are in low and very low in this index. And if we are paying attention only for the Sustainable Development Goal regarding climate action, most of the cities that are very low in this index are concentrated in what we call the arc of deforestation in the Amazon cities. And in terms of indicators, it's important to know that this index for the climate action considers the proportion of houses in risky areas, the risk management strategies and disaster prevention that have been adopted by the cities, the percentage of deforestation, CO2 emissions per capita, and the concentrations of fire hotspots. Next, please. And in terms of financial capacity, this is another important indicator from the National Treasury. You can see that most of the municipalities that consider small municipalities are in this rated as C and D, which means high fiscal risk and difficult accessing the investments and the financing needed for disaster prevention and mitigation. Next. So just to finalize and conclude my presentation, I think that we have 5 messages to think about justice and sustainability regarding Brazilian cities. First of all, we need to recognize this interdependency between the impacts of extreme events, political issues, and the local dynamics of urban planning. The second message is the negative effects of this urbanization, this kind of accelerated urbanization is characterized by social segregation, not only in Brazil, but this is the reality of the most cities in Latin America, combined with the wide gap between the extreme wealth and extreme poverty, and the weakness of social protection systems are being exacerbating with the current climate change. Third, most Brazilian municipalities are not implementing what we call comprehensive climate adaptation policies that could generate social, economic, and benefits. And you see the indicators that we use in UI is not only focused on climate change, it's focused about quality of life, about well-being, about sustainability. There is a need to advance sustainable adaptation, and it's crucial to prioritize climate interventions with the greatest health, social, and economic benefits. And to achieve this, it's fundamental to combine scientific evidence with local experiences, with other kind of knowledges, local, traditional, practical knowledge. So my generation, I think, we believe that science is important to be practiced with and for society. Next, please. Next. So, from insights, from all ideas that we discussed during today and yesterday to actions, particularly in terms of justice and sustainability, I believe that we need to promote and engage in science. We need to reach a responsible research and innovation, which means transparency, gender, but also a diverse types of knowledges, open access, transdisciplinarity. Scientific knowledge is important, but again, other kinds of knowledge, experiences, ways of life are important as well. And we need to co-produce self-knowledge. Otherwise, maybe we are talking a lot about what we have been done to explain the climate change, but we don't affect or we don't improve the conditions for reaching a more sustainable, adaptable, resistance, and just futures. Next. Thank you again. Thanks to colleague researchers, my advisors, students, and particularly the practitioners that have been participating in our research. Thank you.
Thank you. Please have a seat. So I'd like to call Mauricio and Zuzu to have a seat, and the panel is open for discussion. We can. The first question there in the fourth line.
Thank you for the presentations. Gabriel, I have a question. I think what you said almost at the end, this is an index for quality of life, not only for climate adaptation. I think that's very right. I was wondering if you analyze if some of these variables had different importance. Let's say if you weight these variables differently, or you just consider that, for example, having bike lanes is the same as having good sanitation, for example. And if there is a way to cross-check that information, like to have another independent variable at the end that you can retrofit to see if those variables may be having a different weight as well. Like, for example, having another index that is independent, expressing quality of life that you can use to cross-check the index that you've developed. But otherwise, I agree with the statement that not only maps are power, but knowledge is power, and I think science has that power to change things.
Thank you. I'm Philip Fernside from IMPA. I think in the presentations and also in general discussion of climate change, virtually everything that's said has sort of a footnote between the lines that all of this is provided the climate does not escape from human control and have an explosion of warming. You assume that it will continue as has been in the past, increasing temperature gradually, at least up to the end of this century, such as the IPCC scenarios and so forth. But we're very close to various tipping points, both in the global climate system and in the Amazon forest. And if those are passed, any one of them, then the emissions from what are not deliberately being emitted by the human population, by burning fossil fuels and deforesting, for example, will be so much that we can't control global warming. It just gets hotter and hotter. You have more and more forest fires, soil warming, the oceans warming, and so on and so forth. So if that happens, virtually all of the social agenda that we're talking about having, social justice, involvement of indigenous peoples, bioeconomy, and so on, all of that just disappears. If climate escapes from control, you'll have mass mortality, and that just overrides virtually all of this, so that temperatures of heat waves well over 50 degrees, and people will just die, large fractions of the population. And if that happens, you can't expect either government or private institutions to continue normally, so that even those that in the urban elite that have air conditioners and can have electricity and so forth. So you have a totally different scenario that's just hanging over all of this discussion. And I think that, that needs to be included in this. And so it's something that certainly is hanging over the COP that's coming, and that if there isn't a radical change in emissions, that's what we're headed for. So I think this has to be injected in all.
Bom, congratulations e parabéns pela sua apresentação. E a minha pergunta é dupla. Bom, primeiro que nós sabemos que os...
First, we know that the most preserved places, at least in the Amazon, they are probably indigenous places in riverside communities. And well, good job for your work and for making yourself to be seeing. And it's important, things like this have to be present in a COP. So Professor Mauricio, is there, because the entropic effect is not uniform, so you have a great latitude to become a livestock, and there's like small communities, the effect of those small communities, it's totally different. I know that there are things that are extremely hard, but would that be a different of the entropic effect, and how can we do that? Parabéns.
So we can go for the, please. No, please, go.
It's for Mauricio. So the excess mortality that you observe during the heat waves, how is the behavior over time? Because in Europe, we had like 2003, where there was a lot of excessive mortality, especially in France. And afterwards, heat waves have been even worse and during more time, but the excessive mortality didn't increase. So it looked like there was some kind of adaptation. And I would like to hear if that the same happens here.
So I think we can start with Mauricio, and then we go on, and after, and you can answer questions and prepare your closing remarks together.
Okay.
So.
Thank you for the question. I think, well, I don't know how to answer that, the first question. Yeah, look, it's possible, anything is possible, yeah? But you need, depends of the data that you analyze that, yeah? Because a lot of things you believe in that, but it's not true. For example, a few years ago, I published a paper about evaluating the impact of sanitation program in Salvador on health. Was published in the Lancet, the high impact journal. Yeah, Lancet accepted to publish that. Was even selected to be one of the Lancet paper of the years. And why that? Because in the 19th century, people believe that sanitation was important for health. Yeah, there is more than one century. But there was no study about that, yeah? There is no, people believe in that, yeah? But there is no demonstration, empirical demonstration of that, yeah? Then this is one thing that now, I think in the current moment, you request, yeah, more analysis and more information to take decision, at least a so-called informed decision. Then the question you propose, yes, it's possible, but not so easy, yeah, because when you go to small things, there is a problem of numbers, yeah, and then to see and to check difference is very complicated, yeah. Even work with the data of all Brazil, sometimes it's very complicated, yeah, to work in that, yeah. For example, if you put each, because the analysis, some analysis you do by each municipality, yeah, on the during the longitudinal period. The number of events in municipalities sometimes is very small, yeah, to analyze. Then you need to use techniques to aggregate this data to make it possible to analyze and to test difference, yeah. Then depends on the question. Generically, you can say, yes, you can compare anything. Empirically, to do that, you need to really to make it more clear your question and to see if it's possible to test or not. About heat wave, look, there is one discussion heat wave, but there is no discussion temperature, yeah? There is clear that is more increase in temperature have huge impact on the health, yeah? It's not only heat wave. Heat wave kill acutely, yeah? You have a big event, yeah? 3 days of heat waves, die 100 people. It's very easy to identify that, yeah? But the chronic effect of the increase of temperature is a lot more complicated, yeah? Because it's not perceived, yeah? It's not clear in the eyes, yeah? The person die of have a heart attack, yeah? You can have a heart attack due to the different problems. But during a heat wave, you see that you expect to have 100 cases in that period, and you have 300 cases. Why? What happened? Yeah? Because the 200 cases was an excess rate, yeah? Problem associated. You see that in more chronic process that is very small, you need to use the analysis techniques, yeah, to more sophisticated to detect the difference and to demonstrate that this is true. Yeah, this is one question. Then our study for now have been on increase of temperature. You are really organize our data to analyze the heat waves, yeah, during this period and to see acute effects of heat wave. But what I presented is more the chronic effect of a heat wave. And another thing is the attribution, because I think the IPCC some years ago put this in debate, yeah, on because there is some question, Trump say publicly there is no climate change, yeah, everything is variability of the climate, yeah. Then there is this debate, what is really climate change and what is variability of the climate. And if you think in terms of policies, legal terms, yeah, it's completely different things, yeah, variability and the attribution to climate change. And these have come to health more recently, yeah. There is people that start to work with this idea of attribution to health. In epidemiology, you work a lot with attributable risk. Yeah, you have two concepts that are very central in our science, that is relative risk and attributable risk. And then it's not so difficult to us to understand and operate this concept of attributable risk. The problem in this estimate is to estimate the contrafactual, yeah, what's to compare the real situation with the contrafactual. Then come the climatologists with a lot of modeling, yeah, that is one, the climatological science, we have developed a lot of resources, yeah, to create this contrafactual, yeah, that make possible you at least estimate what is anthropogenic and what is, yeah, the contrafactual without the anthropogenic effect. And based on that, you estimate the attributable effect, yeah? Then a problem that you have to, when manipulate big data like this or this situation, then you need to work very careful because there is a lot of question about that, yeah? Anything that you say a question, yeah, there is people in favor and against, yeah? Not everyone agree with that. Then need a very careful analysis, yeah, and is what I think the groups that work in this area, yeah, try to do, yeah, to create a more rigorous science, yeah, to analyze the scientific or the health factors, yeah, on given this process, yeah, of change that is going on in the world. Thank you.
Thank you. Gabriela.
And thanks for your question. We, in our research team, talk a lot about if we need to give different weights for the indicators and for dimensions, or give the equal weight. And in the end, I think that we took the right decision. We gave equal weight for all the indicators and dimensions based on two assumptions. First of all, we think that Brazilian municipalities need to be prepared for different kind of extreme events, or what we call a compound extreme events. So, for example, Rio Grande do Sul last year suffered with a severe flood, which killed more than 100 people, caused many damages, loss in terms of materials, infrastructures. But in the year before, in 2023, the same state suffered with a high drought, with a very big impacts for the economy, for the agriculture. So I gave this example because for me it's very clear that this is the case, that the cities, the states need to be prepared for different extreme events. And also because we built this index based on the information that we got from the practitioners, people who work with us in our project, we also understood that the local governments, the practitioners, are the best people to decide if they want to prioritize one public policy or another based on the reality of the municipality. So maybe in terms of mobility, some of the indicators doesn't make any sense for Amazonian's municipality, for example, but it's okay. But for other cities, some of these indicators could be very important. So again, it's the public, the local government, the local institutional actor that might decide which kind of indicators and which kind of weight actually they can give it to the index. And the second question, how we are now trying to combine this index with other indexes that measure the quality of life, or other information, for example, in terms of scenarios, climate projections, to measure if the cities that might be at risk in the future is a city that is well prepared right now in terms of our index or not. Or another combination of data that we are trying to do. The cities that provide ecosystem services have the best indicators in terms of environmental management. So we can play with this data, with these indicators, but again, the main goal is to provide some good portraits for the population, for the local governments. And what's very interesting, because we published this article in July, and we got many messages, many mails from local governments, practitioners, or representatives of local governments that they are very interested in our information. They are requesting information because they want to see how they are in terms of the index. And the database is open, so anyone can visit it and check how is my municipality right now in terms of these indicators that we build in this index.
Thank you. Tuzu.
Sustainability may be one of the points that should be raised as important, is that having indigenous territories as marked lands, it could be just a landmark for a contention or a solution as well for this climate change. Because indigenous territories, some researchers say that there's, in some of them, they have 1% of deforestation, while other territories, they lose like kilometers and kilometers of forest. Even though it's an intact environment, these heat waves, they are felt by the families. They say that the people who work in their crops, that they can't work the whole day because the heat is still intense, and how this impacts people's health, especially the elderly people. They get headaches, dizziness, and we have to evaluate this impact in their health. So when I say that we directly depend from resources from the territory, I mean that it's an opportunity of the bioeconomy to develop. And there we have our knowledge flowing from our traditional people of what we have about the plants, of what we have about the animals, of what we have about the territory itself. And as I always say in other talks, other meetings, that we need to get together with the local community and the scientific community so we can try to find more creative solutions for mitigations and those challenges. Thank you. Então, eu gostaria de agradecer a todos os palestrantes pelo esse painel brilhante.
Thank you all for your participation. Thank you.
Well, we'll be leaving for a dinner straight from here, so the vans will be waiting us outside, and then we'll relax, have some drinks, and have dinner at a restaurant tonight, not at the hotel. It's a restaurant with traditional food from the region.